So you want to collect computer and setup information. So you need to make sure that you have your product key. And then we want to choose the type of platform, typical, portable, compact, and custom, so you can kind of dictate what's installed in there. The special, like if you want a Telnet server or something like that. Remember, we don't use Telnet. It's very insecure, so don't use it. But that's, you know, the kind of custom you can install. You could select if you wanted games installed or not, that kind of thing. And then we want to create a startup disk and complete the file copy. So this requires a 1.44 megabyte floppy disk. Nobody uses this, right? The startup disk contains real mode files, CD-ROM drivers, and utilities necessary to start in DOS mode. This is if your MBR ever got corrupted and the system wouldn't boot. You could use the startup disk to refresh the MBR and get it straight again. This used to happen quite a bit. These were important back in the day. We don't use these today. A startup disk should be part of a technician's toolkit. Yes, everyone carried several of these around with them. I still have mine. After the startup disk is created, files are extracted from the archive files. So after the startup is created, files are extracted from archived files. Then you want to tune the configuration, right? It's going to kind of tune itself to your computer automatically. And then we're going to get into troubleshooting a 98 installation and using safe recovery. During installation, every action is tracked and logged. If setup fails, safe recovery uses the logged information to try and resolve the problem. To run safe recovery, wait a few minutes and then press Control-Alt-Delete. So it has to collect information and write it out to the disk. And then you want to press Control-Alt-Delete. Hardware detection and system configuration problems cause most setup failures. Yes, something like the video card not being detected or not having the right driver. Sometimes you'll get the BSOD, right? The blue screen of death, and it'll just reboot. Windows logs the point of failure and bypasses that point. You might need to remove a device if setup cannot bypass it. So for example, if there's a board in there that's causing the problem, you just take it out. And then, so this is even true of today. If you have a computer that's malfunctioning and you have no idea what it is, just start unplugging everything. Obviously turn it off first. And then unplug everything. Hard drive, CD-ROM, whatever you've got in there, just unplug it from the motherboard. So everything's just kind of sitting right there. And then start to boot it and watch it and see what it's doing. If it seems to be working, turn it back off, plug one thing in, turn it back on. Plug one thing in, turn it off, plug one thing in, turn it back on again. Until you get to whatever's causing the problem, right? So you just do it a process of elimination, unless it's obvious what it is. Beyond safe recovery. So we want to use manual intervention when safe recovery is not sufficient. So if skipping a driver is not enough, then we've got to go in and start doing what I'm saying, right? We start swapping out, we start pulling cards and stuff. Use manual intervention. So we want to review the planning process first to make sure there is no critical issues we overlooked. So this might be useful in the enterprise environment where you have a lot of stuff going on. So it could be software first, right? We use the information generated by the failed installation to help solve the problem. So it's going to kind of give you a hint as to what it is. Most of the time, when a system failed to boot, it would give you a memory address. It would throw up that error, and you could just Google that memory address and it would tell you what it was. Or, you could do a dogpile search or something. And Microsoft had lists, because these were all common, right? It would have a list of what each memory address was involving. You might see, oh, that's the video card's bad, that kind of stuff. So to use this information, you must understand hardware detection. The hardware detection process. Setup attempts to detect devices that are installed on the computer. Each plug-and-play device is queried and configured. So each plug-and-play device, the motherboard will go and talk to it and say, hey, give me your information. And it says, hi, I'm a Cisco networking card, generation 3, here's my serial number. It gives it all kinds of information for the plug-and-play, right? And then they negotiate on interrupts and all that kind of stuff. It's all done for you. Plug-and-play device settings are discovered and cataloged. 4 classes of devices are detected and located by safe detection. 4 classes of devices are detected and located by safe detection. You can skip a certain class of device during setup if a device might cause problems. So that's what safe mode was about. Safe mode literally skips every driver, every single one. And then safe mode with networking will skip everything but the networking. So it'll add that for you, and that's it. So that's why it drops out to that really dull color, small, big resolution. Just the most default should run on any monitor. It skips all of the drivers. Okay, so set up log files. We have bootlog.txt, which creates and holds a record of the entire boot process. So everything as it's booting is stored in here. So if you compare this run where you're having problems to the last one that was successful, well then, hey, you can probably figure out what's going on, right? And detect crash.log shows resources accessed when the failure occurred and invokes safe recovery when the system is restarted. And DET log is the user readable version of detect crash log. So the DET log is what you want to look at when you think you want to look in the detect crash log. And the netlog.txt describes the network components found in the system. And then the setup log.txt is used for safe recovery if setup fails. Performing a Windows 2000 installation. If Windows 2000 setup is similar to Windows 98 setup, but with some important differences. So they're saying this is Windows 2000 setup is similar to Windows 98 setup, but with some important differences. Employing NTFS involves different installation and management procedures. So employing NTFS involves different installation and management procedures, right? Because it's more complicated. It's a completely different file system than what we were using previously. There's a lot more information in there, but it's much more hardy, so it's a lot better than the fat file systems. The more robust security of Windows 2000s adds a few extra steps. This is true. That file system had a lot of security features in it. All those extra bits were used for security features. So not all of them, but a lot of them were. So preparing and planning. Remember that the hardware compatibility is much more important in Windows 2000 than in 90X series, right? 98, 95, ME, all those, 98 SE. We want to check the hardware compatibility list for Windows and check the hardware vendor's website if you cannot find the hardware on the hardware compatibility list, right? So if you can't find it on the Windows list, then go out to the hardware manufacturer and say, hey, are you compatible with Windows or not? Upgrades and updates. The system components must have the most recent version of the firmware. Well, we know about that, right? The basic input output system, the bigger hard drives. Every time you bought a bigger hard drive, you had to reflash the BIOS back in the day. We don't have to do that today. The system bus must support the Advanced Configuration and Power Interface, ACPI standard. Advanced Configuration and Power Interface. The system bus must support that. And then failure to upgrade the BIOS can seriously damage a component. So if the BIOS tries to access something that it shouldn't be accessing, or tries to write something to a certain point, space in memory, it can cause some problems. And remember that Windows 2000 information gathering process is similar to Windows 98 process. So now we want to choose the name and initial password for the administrator account created during setup. Make sure you write that down. You don't want to lose that. And then gather the names and passwords of any other accounts that need to be created after installation. Again, you might do that in a Soho where you have 5 people in an office. Any more than that, you're probably using like Active Directory or something like that. So all that's done on that system. You don't do it this way anymore. This was really old school. Upgrade or clean install. Again, we've beat this to death, right? So setup offers to upgrade if it detects Windows 95, 98, anything previous, right? An upgrade officially configures and migrates settings from the previous installation. A clean install on a system with an existing OS will install Windows 2000 in a new directory. So it preserves all of the files that your old system had, every single one. So this is true, it does do this. So if you installed Windows 98, so if you just sat down on a computer and you go into the C:\Windows directory and you see Windows 2000 and Windows 98, you'll know that they originally installed 98 and upgraded to 2000. So the system can be configured to dual boot. Why? Because 2000 dual boots and you install 98 first and then 2000. 2000 will give you the option during the installation to dual boot. And it's leaving all of the files intact, so there's no reason it can't dual boot, right? We just talked about that. All the 2000, we're not replacing anything, we're just installing them in parallel. So it takes a little bit more space too. So the CD-ROM, floppy drive, or network installation. Are we installing from a CD-ROM, a floppy disk, or network installation? The simplest installation to boot from is to boot directly from the CD-ROM, right? If the CD-ROM is not supported or bootable, you can create and use setup disks. So use a little floppy disk and all the files will be on the CD-ROM. You can also install Windows 2000 from a network location containing the source files. Creating Windows 2000 setup disks. Use a computer with a CD-ROM and any version of MS-DOS or Windows. Format 4 floppy disks and label them Windows 2000 setup disk 1 through 4. Place the installation CD in the CD-ROM drive, and then you want to type this command, boot disk, make boot a : at the prompt. Insert the first floppy disk into the floppy drive and follow the directions for each disk. So I've done this before, it does work. But again, we don't do that today. But you might do it with a flash drive, so you might make boot and then use the flash drive, it's possible. Starting setup and using setup options. So Windows NT 32XE can be executed from a 32-bit OS and can be used with several options, /s, temp drive, unattended. Unattend means don't give me any prompts, just install the thing. And then / command debug UDF syspart check upgrade only. And then the Windows NT can be executed from a 16-bit OS and can be used with several options. So you could boot it and use it. You didn't have to install it. And then the step-by-step installation process. So yeah, I guess you did. These are the starting setup and using setup options. So these are for setting it up. And then the step-by-step installation process. We want to choose a file system and disk partition, perform disk validation and file copy, complete the primary device detection and information gathering, begin installing once all information has been gathered. Okay. So the one thing you need to remember here, if nothing else, is that you need to create the system that you're going to boot from needs to be the primary partition, okay? Don't forget that one. That is a test question. Post-installation task. So once we've got it installed, we want to set up local user accounts, we want to join networks and domains, and we want to create an ERD, an emergency repair disk. Again, that's a floppy disk or a flash drive. Troubleshooting a Windows 2K installation. We want to check hardware and software by running check upgrade only. See if there's any known problems that it's detecting on its own. Repeat the installation after checking the compliance. So if you try it and it doesn't work, you run the / check upgrade only and then try and install it again. And then you start digging into the logs, right? So we want to inspect the logs, set up ACT, set up API and events. And then we want to simplify the hardware configuration, start removing stuff and see if one of the cards is causing a problem. Obviously, we've seen this a few times. So if you're troubleshooting an installation, it's likely some add-on card, right? And then we want to use a recovery console for basic repairs. So in summary, the Windows family of OSs includes a variety of products tailored for different environments. True. Windows 2000 is the most robust version of Windows. True for the test, right? And then proper planning and system preparation are critical. Okay, for the test, proper planning and system preparation are critical, okay, for the test. Windows 2000 installation requires more careful planning than does Windows 98. The Windows 98 and Windows 2000 installation processes are somewhat similar. Windows provides tools for troubleshooting installation problems. And additional tasks are required after installation is complete, like adding to the domain, right? We want to set up local accounts, join networks and domains, and we create emergency repair disk, right? Additional tasks are required after installation is complete. What are they? Set up local accounts, join network domains, and create an emergency repair disk.